Hi, my name is Joshua Pai, and this is my informative speech. And this is my audience right here. They're all on Discord call because they can't make it in person. Okay, I'm gonna mute them really quick so that they don't make too much noise. Okay, cool. Hi, my name is Joshua Pai, and today I will be doing an information speech on quantum computing. I remember back in elementary school, I was forced to memorize the multiplication tables, as a lot of us were. And I remember I sacrificed a lot of my time in order to memorize these things, sacrificing time such as television time. And I remember I absolutely despised my teachers because of this. I really liked the show called Kid vs. Kat, and the multiplication tables forced me to focus more of my time memorizing these multiplication tables than being able to watch that show. But I remember going into middle school and taking my first algebra class where I was introduced to this thing right here, a calculator. And I remember when I was first introduced to this, I was really mad because I felt like, why was I being forced to memorize this multiplication table when this existed? Having to memorize all of those and then realizing that this could do it within the span of 2 seconds without having to memorize anything really ticked me off, because I really just could have been spending time watching TV instead of memorizing those tables. However, I was also really surprised by this innovation because I haven't really I've seen it obviously before, but I haven't really used it in a way that would benefit me. So then when I was using it in algebra, I was like, wow, this is an amazing piece of technology that really helps out mathematicians, I guess, or people, not mathematicians, just kids doing basic algebra math. And although these things are great, there are a couple of things there are complex problems where a traditional calculator is not enough to be able to solve these problems. And an example of this would be algorithms, where this cannot compute an algorithm. And that's where quantum computing comes into play. So quantum computing was developed in order to solve problems like that a traditional calculator would not be able to solve. And in my speech, I will be discussing the recent advancements in quantum mechanics and the benefits and drawbacks of quantum computing. According to Daniel Leiter in his What is Quantum Advantage, published by The Conversation in 2017, he says, and quote, "Quantum refers to the scale of atoms and molecules where the laws of physics as we experience them break down and a different counterintuitive set of laws apply. Quantum computers take advantage of these strange behaviors to solve problems." So basically what he's saying is, we use quantum physics in order to develop quantum computing. So instead of abiding by the normal laws of physics, we use quantum physics in order to be able to complete these computations faster and quicker. And we use them in a way that can be used to solve complex problems that these things cannot solve. And in another article by Chris Woodford called Quantum Computing, published by Explain That Stuff in 2023, and he says, quote, "Quantum computing means storing and processing information using individual atoms, ions, electrons, or photons." So this further ingrains the fact that quantum computing uses quantum physics in order to better compute and solve complex problems that, again, traditional calculators cannot solve. And we also see that our extensive research and knowledge into quantum physics has been used in order to develop a new system that would greatly benefit researchers and entrepreneurs alike who need new development such as quantum computing in order to help solve their complex problems that we can't even comprehend, that only people like that can, or we're not well studied and prepared enough to understand and solve those problems. So although quantum computing sounds like a great and wonderful idea, and it is, there are some drawbacks to it that still have, just because it's so like new to our society that we have yet to master this type of technology. So, in another article by Honghui Shang in Towards Practical and Massively Parallel Quantum Computing Emulation for Quantum Chemistry, published by NPJ Quantum Information in 2023, says, however, existing simulators mostly suffer from memory bottlenecks, so developing the approaches for large-scale quantum chemistry calculations remains challenging. So basically what he's saying is that currently our hardware and technology is not advanced enough to support this new quantum computing process. So because quantum computing is so relatively new, we haven't had the time to be able to upgrade our current hardware to support quantum computing, which causes like a big bottleneck. So just because we aren't able to, or we have the software to run it, but we don't have the hardware to back it up, if that makes sense. So in a way, it gets bottlenecked. So we only use some of quantum computing. We can't use all of it just because we don't have enough support to be able to support quantum computing at its full potential. So to conclude, we have explored the groundbreaking field of quantum computing and its potential to solve complex problems that normal traditional calculators cannot solve. Although quantum computing may seem like although quantum computing is a great technological advancement, we are still barely scratching the surface, and we need more research and time to be able to develop and create support systems that would support quantum computing to its fullest potential. And just as this calculator once amazed me in solving basic arithmetic problems, quantum computing can then greatly amaze everybody at what it can do for our society. Thank you. Good.